And thanks everybody for tuning in once again to another daily space weather video. I'm your host Dan, aka smAsho, and we'll be talking about cosmology links today, some interesting ones we found last night. Shout out to Anton Petrov. Thanks for your latest video, at least it was last night your latest video. We'll be talking about low clouds, an earthquake in Taiwan, coronal hulls, and how you should subscribe if you haven't yet. Thanks to our new subscribers, viewers, etc. So here at the Smash News Network, we typically start things out by looking at the local yellow dwarf here. Here's a 335 angstroms one-day video from the SDO, one of the ionized iron emission states. It's part of the UV spectrum of light, and we see one sunspot in the southeast with some flaring happening there. You can see a little bit of flaring, several B-class flares happening, nothing major going on, no major coronal mass ejections facing the Earth or anything. There is a minor coronal mass ejection sort of in the Earth-facing vicinity, as well as one on the far side, nothing to really write home about. Here's the view from the LASCO C3, the zoomed out coronagraph, and you can also see Mercury there on the right. That little coronal mass ejection there, mainly over in this area. Let me draw that in. Over here somewhere. And again, it's quite small and minor. Most of the plasma suspended out there in the corona between the Earth and Sun right now is sort of still attached. The 10.7 centimeter radial flux still at 82, having dipped way down from its highs that we recently saw. And there's the 1 year chart. You can see it made it all the way up to, I think it was 116 solar flux units. And you can view that data yourself at solon.info. There's the multi-year chart of the 10.7 centimeter radial flux, which for you new viewers is a measurement of the radio output of the outer solar corona. And you can see that it's, well, if I zoomed in, you could see that it's proportional to the sunspot number. There's sort of the same basic portion, and you can see how similar the radio flux is to the sunspot number. Next, we'll look at the colorized magnetogram, and I apologize for that flashing. I don't know what that's all about. Let's get that off screen entirely. Warning, may cause seizures. All right. And we've got some HelioViewer movies for you. We're going to show you some at the beginning and some at the end of the video. So here's one of them. That's the 304 angstroms full disk video. And again, there are a bunch of plasma filaments in between the Earth and Sun here, not particularly visible in this view, as there's not a lot of contrast from this angle. We'll show you the view from stereo A also, and you can see a little bit of those solar flaring behaviors in the southeast. And again, for you new viewers, this is the western side of the sun because this is where solar weather sets as the sun rotates, and this is the eastern view. This is the eastern portion because it's where solar weather rises. And we've got a whole bunch more, well, we've got about 3 more HelioViewer movies here that we'll be showing you. If I could regain control of my browser. All right. I would also encourage our viewers to become patrons and help support our barely even begun operation here. Thanks to our patrons. Become a patron at patreon.com/smashamash. Consider joining at the $3 per month or more level, as we will be eliminating the $1 and $2 tiers by New Year's Day. So for all you patrons who are at the $1 or $2 tiers, please consider upgrading by the end of the year. Did you view yesterday's Smash Lights segment? We did a lengthy, an hour and 40-minute video just about various different things. Perhaps check that out. You can find that in the playlists. Also, check us out on social media. We're on Facebook. We've got a group called Entropy Busters, as well as facebook.com/smashamash. We're on Twitter. We've only got 106 followers. And if you enjoy the content on YouTube, please press like and subscribe over there. We've got links, etc. on the YouTube page. Also, check out our smAsho.org Presents the Sun series. Got some great videos in there with all kinds of close-ups and various different wavelengths of the local yellow dwarf. Thanks for everybody tuning into those. Also, I would invite all of our viewers that view the Daily Space Weather to make sure you tune in on December 21st at 5:02 a.m. Eastern Time, 20 seconds after it actually, 5:02 and 20 seconds Eastern Time. We'll be doing a live stream to wish you all a happy solstice. And we typically always stream a live video at the moment of the equinoxes and the solstices. It's one of the signature features of the channel. Again, youtube.com/smAshomash. Thanks to our BitChute subscribers as well. There is some exclusive content on all of our social media sites. We are streaming live to Twitch. It's my favorite live streaming platform. YouTube's okay too. And again, we've got to put up exclusive content in all those locations. Cheers to those at it's twitch.tv/smAshomash, and perhaps download their mobile app. It's free and it'll send you notifications when we go live on Twitch. Also, we've got a Discord channel. You can link to all of that at smAshomash.com. And let's talk about some cosmology stuff. So today's cosmology segment, we're not going to roll any dice and look at a random object. And by the way, little background, the reason that I do this is to challenge myself to look at these objects and give some sort of a explanation of what it is without doing any research. Because, well, I know a bit about this stuff, and to quote Jordan Peterson, I prefer to talk about things that I know something about. So, check out our forum, smAshomash.com/forum. We've got a cosmology forum there, as well as Earth and geophysics. And that guy who was commenting yesterday, Care 29, whatever, please put up a post in the Earth and Geophysics Forum, as the generation of Earth's geomagnetism is a very important subject, and we're very interested in it. And if you've got something to post about cosmology or the sun or really anything at all, there's even a free-for-all forum there, smAshomash.com/forum. Again, you can link to all of that at smAshomash.com. There are all of our social media links. Shout out to Smash staff. Consider giving her a raise by becoming a patron, or perhaps checking out some merch at the Smash stores. And there's the link to the forum and the Smash stores. Today's featured product is the Condensed Matter Matters shirt. It's printed all over. It's on the front and back. And there's even a 304 angstroms view of the sun. I think that's Sunspot 2786 also. As well as the website. Since condensed matter matters, we decided to make a shirt about it. And there are other cosmology-themed products there. Look for more coming, possibly even by the end of the year. And don't forget to enter the promo code SMASHO at checkout to save 10% on all orders. One reason to subscribe to the channel is our community posts. As we don't only make video content, we also refer other videos. So, we look at the whole thing as a collaborative effort. And let me just check the life of the stream here, speaking of collaborative efforts. Thanks everybody who leaves chats. And thanks everybody who views our live premiere events. Part of the reason why we view the live premieres is because I'm not only smAshomash, but I'm also a client. And I'm also the editor at large. So again, make sure you subscribe, press like, press the notification bell, and most of all, share on your social media, especially if you're an influencer. Thanks to everybody who does so. And I would just refer you to our latest community post. And once again, shout out to Anton Petrov. So Anton Petrov is a massive YouTuber. He's got millions of subscribers. And the video he put out yesterday was very interesting, as it's got this link. Now, our patrons already know about this. We showed them it last night. And it's this great website you can view about a phased radio astronomy array located in the Australian desert, and talk about a fantastic app. This works great on my phone. I'm currently using the Opera browser on my phone. And this is a massive radio astronomy site. So you can zoom way in. This line here, that's the Milky Way galaxy plane. And there are all these radio images. There's M83, which is an active galactic nucleus. You've got all kinds of supernoval remnants. And radio astronomy really is the wave of the future. So back in the mid-90s when I took astronomy in college, I was fairly unimpressed by radio astronomy. Now I'm more than impressed. So there's a supernoval remnant. And you can even check out Sagittarius A star. So again, make sure you subscribe, as you may not see our community posts otherwise. You can find all of that at youtube.com/smashamash. Also, we'll be messing with the space engine. So spaceengine.org is one of the things you'll be seeing soon in our cosmology segments. So look for that. We'll be making more interesting content here. We haven't done a pure cosmology segment for quite a while, although we do have a playlist. I think there's like 100 videos in there. Perhaps check that out as well. We've got a bunch of playlists. youtube.com/smashomash/playlists. And that's about all I have to say about cosmology on this delightful day. Let's get back to some solar data. The real-time solar wind was pretty much a dud regarding the geomagnetic storm. Let's check the current conditions. We just saw a recent shift in the phi angle coming out of coronal hole magnetism and going to an area closer to the 0/360 degree mark. Yes, the phi angle is in degrees. And at the same time, we saw the BTBZ go well into positive territory there. North solar polar field looking strong at the moment. BT is at 6, that's the total field, and +5. So positive field, +5, north polarity. Current solar wind density 5.16 protons per cubic centimeter. Current solar wind speed 476 kilometers a second. The KP index, a measure of global geomagnetism, currently at 1. Next, looking at the geospace magnetosphere movies, here's a visualization of the magnetohydrodynamic pressure. Saw a little oddity there. What was up with that? Was that missing data? Yep, we got missing data. We've got an hour and a half of missing data right there. As you typically don't see a pulse that sudden. That would be something as ridiculous as the idea of crossing the galactic current sheet. I won't get into it. That would be saved for a cosmology segment. And shout out to Eugene Bagashoff. Make sure you subscribe to Eugene the Philosopher. Perhaps we'll talk about one of his videos later. In a later video. So you can see here the data's going from 7:30 to 9 o'clock. A little bit of missing data there. It's supposed to be 4 hours of data. I'm not going to do the math and figure out how much it really is. There's some data regarding ground magnetic perturbations. And you can see the main ones are over the Canadian North Pole, not the Siberian one. And the South Pole, evidence of that having crept into the southern Indian Ocean. The proton flux has calmed down here. Nothing to write home about that. And there's the 3-day chart of the X-ray flux. That is solar flares, which, by the way, aren't necessary for a coronal mass ejection. We've covered it many, many times on the channel, as we've got over 500 videos in the Daily Space Weather playlist. Next, we'll take a look at a star chart. And I like to use in-the-sky.org. I like to face my star chart to the south, as I'm currently facing to the south. You may see the moon if you're up before dawn. And you'll see Venus ahead of the sun also, perhaps. Here are the coronal mass ejections I was talking about. You can see a minor one right here on the Earth-facing side. It sort of looks like it'll miss to the southeast from both the LASCO C3 coronagraph and this stereo A coronagraph 2. A more significant coronal mass ejection on the non-Earth facing side. Both pretty minor there, though. And you can use the Integrated Space Weather Analysis Center to watch that unfold throughout the day. And also you get to see Venus there, swinging around the back of the coronagraph with respect to stereo A, which is located at Lagrange point 5. So if you're not familiar with stereo A, that's where it is. It's at Lagrange point 5. Lagrangian points are areas where we can put a spacecraft where it will orbit that location with minimal use of fuel. It'll basically want to stay there and just orbit around with the Earth. If you're wondering where Nibiru is located at L3. Just kidding, folks. It's not a thing. If there were planets floating around in the solar system, even amateur astronomers would be able to see them through the process of occultation, where you're looking at a star and something gets in the way of it. Even a non-light emitting object would be super obvious if it was floating around in the solar system. Occultation. Here's what's going on in the solar system. Here's what's not going on in the solar system. OMG, Nibiru, it's going to come out of orbit and it's going to kill us. Not a thing. Although we welcome everybody to leave us ridiculous comments about it, please don't make a fool of yourself in the comments. We will not delete them. Although we may berate you publicly. Next, looking at the GOES magnetometer here, and we're seeing spiky data, as well as some arc jet moments, probably a CCD bakeout for the GOES 16. A CCD bakeout is when the charge coupled device shuts down to prevent itself from being damaged. So there you can see the 3-day chart of the GOES magnetometer, and it's going to look a little smoother in the next 2 days, and here's why. We're looking at the top view ecliptic plane field plot, and you can see the Earth is solidly in the North Pole current sheet, shown in green. And you see how smooth this area is here? That will show us some rather smooth GOES magnetometer. And a smooth GOES magnetometer reading would be like this. Midnight, midnight, noon, midnight, etc. And we see a significant coronal hole here associated with the North Pole, making it all the way down to the solar equator. That could provide some enhanced solar wind here. We'll be keeping an eye on it. And when I say eye on, well, the pun is intentional. Here's a line of sight field plot, which also shows the B field like the last slide, but it also shows the solar poloidal fields and the magnetometer. It's all part of the National Sunspot Observatory. It uses 51 ground-based magnetometers as well as magnetometers on stereo A and stereo B. Next, we'll look at the magnetic field plot of the corona, which is quite chaotic. It's the sun's atmosphere. This is the magnetic environment of the sun's weather. And it doesn't really tell us a lot about whether a coronal mass ejection will happen. I just think it's a cool graphic. And it is showing you closed potential field surface source lines in pink, open ones in purple or black, depending on if they're polar or coronal hole. And next we'll talk about things like charging hazards. We don't see any. Here's the 1-year graph of the electron flux. And electron storms are what cause charging hazards to satellites and communications breakdowns. By the way, we're expecting an electron storm coming, although perhaps it'll be a bit weaker than expected originally. There's the forecast, and I would concur with this. Expect to see some GPS errors and some minor satellite charging hazards over the next 3 days. There's a 3-day graph of the GOES 16 electron flux. So again, expect this to be up in this area, especially around noon local time, which is what the N's and M's mean. That's noon local time for the GOES 16 satellite. Here's a visualization of the electron content forecast, and you can see those very low levels of electron flux there. pretty minor errors for your GPSs, even located around the equator. And we do see some anomalies here over Antarctica. And a little bit over North America also. They're, again, quite minor. So there's just a diagram of the Van Allen belts and where spacecraft are located. The inner and outer Van Allen belts, the International Space Station, the Solar Dynamics Observatory, and so on. And we like to show this daily also, and I like to vanish daily also. Sorry, I can't divulge my secrets of invisibility during the daily space weather videos. And I just like to put this up so people understand the layers of the atmosphere, as they're super important. And if you look over on the right, you can see the D, E, and F layers of the ionosphere. Here's a visualization of the current data, courtesy Australian Government Bureau of Meteorology. And the ionosphere is looking fairly normal here as we approach the solstice, which makes it summer in just a little over a week in the southern hemisphere, and winter up here up north. And for you new viewers who don't know where we're located about here in Lehigh Valley, Pennsylvania. Let's check volcanoes. I like to use volcanodiscovery.com. What's erupting? Well, Kluchevskoy. It's producing a 23,000 foot above sea level ash plume. Also, Abiko, 8,000 foot ash plume there. Suwanosejima, flight level 050, that's a 5,000 foot ash plume. Dakono's exploding, a 2,000 foot higher ash plume there. Don't fly your hang glider over the caldera. It could make for a bad time. Fuego's exploding, as well as Sangre Revenador. And intermittent emissions of volcanic ash from Sabancaya are a reminder to not attempt to do the Triple Lindy featured in Rodney Dangerfield movie Back to School over the caldera. 14,000 foot ash plume at Revenador, 24,000 foot ash plume at Sangre, and 15,000 foot ash plume over Fuego. Largest earthquake of the past 24 was a 6.1 magnitude in Taiwan. And I would note once again, if you're in these locations, have an earthquake plan, because we're seeing a massive and lengthy drought. I'm even going to say these areas. We're seeing a massive and lengthy drought of 7, 8, and 9 magnitude earthquakes, and those droughts end in earthquakes. We actually saw a tsunami a couple of months ago from the Aleutian Islands, and we actually saw that tsunami strike both Alaska and Hawaii. So be on the lookout for that, as we just saw the first 2 proton events of cycle 25 subside. And we see some deep quakes as well. So a 5.4 at nearly 600 kilometers depth at Fiji, the deep quake capital of the world. A 4.5 deep quake at Chile. And that 6.1 magnitude quake came in at 13:19 Universal Time yesterday on 12/10. A deep quake strikes Tajikistan. A very deep quake strikes the Philippines there. It's a 4.3 at over 500 kilometers depth. The Kermadec Islands, north of New Zealand, a 5.9 magnitude quake at nearly 100 kilometers. And then only 6 minutes later, a 5.9 quake at Tonga at the surface. How about them apples? So an interesting series of quakes there, a lot of deep quakes, an extremely shallow quake 300 meters above sea level here at Petrolia. And how we have a quake 300 meters above the ocean, I wouldn't know. Seems a little bit sketchy to me. And keep in mind, folks, earthquake depths, excuse me, earthquake depths are highly model driven probably an indication that there are some errors going on. How did an earthquake emanate from 300 meters above the ocean? Also, we see a deep quake at New Zealand. That one's actually under the island, it looks like. Just north of the shore there. And that was at 230 kilometers depth. Here's a deep quake at the Philippines once again. And another deep quake, so a spout of deep quakes there, a ton of them. A 4.4 magnitude is the last one to report here at Argentina. Next, I wanted to look at low clouds. And the Earth has got a ton of low clouds, and I just wanted to briefly discuss low clouds. Low clouds are the kind of clouds produced by cosmic ray flux. So we're not going to cover cosmic rays today. Perhaps tomorrow we'll look at it. Lots of low clouds here, as reported by windy.com. Let's see how they'll move according to the GFS forecast. We're going to do a GFS forecast for low clouds. And you can see lots of them over the Atlantic Ocean. And here's some of me. Looks like a low pressure system there, south of Greenland. We'll let this advance until about 12 noon tomorrow. Again, it's the GFS forecast. There's where it expects things to be at 12 noon tomorrow. Let's go back to pressure, which is typically what we show. I'm not under pressure to show it. I do it at massive personal expense. There's where pressure cells will be. It looks like a significant low pressure there over the Indiana-Michigan border. Let's rock it back. That's the GFS forecast. There's where the GFS forecast claims pressure will be at 12 noon tomorrow. And let me just check the life of the stream here. We are good to go. Next, looking at nullschool.net. There are the jet streams of the Western world. It's the 250 hectopascal winds. And there is the scenario for the Eastern world. Some very cold air being injected into Central Asia, coming straight down from the geographic North Pole. Some Christmas weather for people who don't celebrate it, for the most part. And next we want to look at lightningmaps.org and see where lightning strikes are happening. Not so much lightning right now. Here's the Go 16 lightning mapper. Nothing too exciting going on there. And I've lost control. Oh my God. We are out of control. We are out of control, folks. And we're back in control. And there's the U.S. Doppler radar map. And we're seeing me click on things that I did not click on. Something that occasionally happens when you're using junkware at the Smash News Network. Cheers. Shout out to Microsloth. If you're wondering what OS we're running, it's Windows 10. And that may not continue forever. More on that later. Putting moron in the term moron. It's me, Dan, aka Smasho Mash. So anyway, here's an animation of the U.S. Doppler radar map. Some rain and snow in the center of the country, as well as in Washington and Oregon. Here's what's going on in the cloud layer. Here's what's going on in the water vapor. Cloud layer. Water vapor. Cloud layer. Water vapor. And once again, this portion is sponsored by Spitfire Wheels. I'm just kidding. We're not sponsored by Spitfire Wheels. Again, I do this at massive personal risk and expense, so consider becoming a patron and sharing the content on your social media. And perhaps pick up a Condensed Matter Matters all over print shirt. So again, you can see these low clouds here. This is a visualization of the shortwave radiation map courtesy of NASA GOES Interactive Weather Satellites suite. It's the 3.2 nanometers, 3.9 nanometers rather. And we're going to zoom in on the Outer Banks here, just for the fun of it, as I am a real meteorology nerd, and perhaps we'll do weather videos in the future. It could be help us go full time by helping to support the channel. And you can see all those low clouds there. We'll zoom in on that same area in water vapor to show you the relationship between the water vapor and the clouds, as they're not always evident. So there's the cloud layer, and there's the water vapor map. Some sudden cloud nucleation happening there off the coast of North Carolina. And that's just for all you weather pornographers. And you can see an upper level series of clouds here moving over the top of those low clouds. Low clouds are very distinctive in the way they behave. It's not contrails, it's not chemtrails. Not all things in the universe are electric, but the weather largely is. And let's move on to bonus features. I'd like to thank everybody for flying American Smashways. Please keep your head and arms inside the smash plane at all times. We're going to show you the Colorized Magnetogram. We're going to show you the Intensitygram. And then we're going to show you the other HelioViewer movies that we created today. Create your own at helioviewer.org. Again, I'm not paid to say that either. It's done at personal risk and expense. Here is the only sunspot on the solar disk. It looks like it's degraded from this perspective. Let's look at it from this perspective. And it's actually gotten more complex here. It's become a beta-class sunspot again, so the likelihood of solar flares and coronal mass ejections goes up a little as a result of that observation. And we certainly did not expect to be the world's leading solar forecaster, but here we are, so might as well do it as it's part of the 5-year and indeed 7-year plan. So here's the full disk HelioViewer movie in 193 angstroms. And somehow I clipped the poles. I don't know why I did that. Here's me vanishing. And we can see a little bit of the evidence of that coronal hole. There's a large North Pole coronal hole in this area. It's difficult to see, but we'll be showing you. Once it's more able to be seen. Here's the 94 angstroms view, which is great at showing solar flares. It takes more images per minute, 5 times as many images as all other wavelengths except for 131 angstroms. So you can see a little bit of activity rising there in the southeast as well. You can see the solar flares that have happened in the past 24 associated with that sunspot area. Actually, that's an active region there. That's not even a sunspot. The sunspot is the area closer to the southwest setting mode. So perhaps some activity rising and setting there. And lastly, my favorite wavelength, 171 angstroms. A popular choice. So thanks again for tuning in, everybody. Thanks, new viewers, etc. Don't forget to press like and subscribe, share on your social media, become a patron. Visit our websites, order some merch, and we'll see you next time. Welcome to the Neo-Renaissance, and since it'll never be now again, may that solar wind be at your back.